So for the final project, we are using a NeurIPS polymer dataset comprised of smiles and other bulk property descriptors that, when in tandem with RD-Kit descriptors, will help predict thermal conductivity for the purpose of optimizing thermal paste formulations.
The methodology consists of three major parts. The different feature combinations are pre-processed and fit into the linear dummy model and the two preliminary models, where the best combinations of features are adopted into the final pipeline. Hyperparameters are also tuned, and their range are found in the preliminary models. And once the desired model is found in the final pipeline, the result model will go through interpretation and uncertainty test process. The final pipeline will give an optimal model for XGBoost with the R-square in test set of 0.82. Almost similar performance was observed in KRR, with a lower drop in the R-square between test and trace set. Therefore, detailed comparison between the two models was conducted, where it was observed that KRR model slightly outperformed XGBoost in most aspects, except max error. This can be explained that because we did not remove outliers in our train sets.
We have compared the model performance of kernel and XGBoost. Kernel has a lower R-square difference between the test and the trained set data, which indicates a very less overfitting. On the other hand, XGBoost has high R-square values. However, hyperparameter tuning significantly reduces the overfitting, and XGBoost performs extremely well with high TC values. The final pipeline results: the trained set R square for the final pipeline is 0.959 and the test set is 0.819. Hyperparameter tuning significantly mitigated the overfitting issue, and hence it confirms that the optimized pipeline is significantly more stable and robust.
So for feature importance, we performed permutation, which informed that RG, rotatable bonds, and density are the most important for the task. RG characterizes spatial extension of the polymer, which for high RG values denotes greater thermal transfer, and rotatable bonds, it directly influences RG based on how it influences mobility. And given that density has a greater importance than log P, it's interesting because log P actually has greater correlation value to TC. So we conclude that XGBoost and kernel ridge are similarly high performing on our chosen small dataset based on our processing and pipeline design choices. But for our future considerations, optimal hyperparameter range could be better defined, and based on the limitation of physical chemical RD-Kit features, all the intricacies within the structure property relationships may not be captured and may be captured differently in other representations such as topological data. Thank you for listening. More info can be found in our appendix of our report or our GitHub repo listed here.